Okay, so we're solving quadratic equations. You always want to make sure that your equation equals 0 before you solve it. So does this equal 0? Yes, all right. So what form of your quadratic equation is this one in? Standard, factored, or vertex? It's in factored form. So when it's in factored form already, we can just go ahead and use the zero product property right off the bat. So I have 3 things being multiplied. I've got 3 being multiplied. I've got this parenthesis being multiplied, and that one being multiplied. One of those things has to be 0, right? Because if I multiply them and it equals 0, something has to be 0. Can 3 ever be 0? No. So I can just ignore it because it's not going to be part of my solution. But x minus 5 could be 0. So I'm going to write that out as its own equation. And 2x plus 3 could be 0. So I'm going to write that out as its own equation. So now I've got 2 equations that I can solve for x. I'm going to add 5 to both sides to get rid of this minus 5. And that gives me my first answer, which is x equals 5. I'm going to subtract 3 from both sides to get rid of that plus 3. That gives me 2x equals negative 3. Divide both sides by 2, and I get x equals negative 1.5. Those are your 2 answers. These are the 2 numbers that make this equation equal 0. Now, if you saw that 3 out in front and thought, oh, I have to distribute it to get, before I can do anything, that's fine. You'll still get the same answer, but make sure you only distribute it across the first parenthesis. Or save yourself some time and don't distribute it at all. Okay, any questions on that first one? How many of you guys got that one right? Okay, fantastic. Awesome. All right, let's take a look at the second one. What form is this second equation in? This one's in standard form, which means that before I can solve it, I got to get it to factored form. Is it equal to 0? No. So before I factor it, I need to make it equal to 0. And the way that I make it equal to 0, since it's equal to 9, I would subtract 9, because 9 minus 9 equals 0. And that would give me 3x squared plus 4x minus 15. That's what I'm going to factor. So I'm going to do my area model and my diamond. And I've got 3x squared down here. Negative 15 goes on the diagonal with it. Multiply them to get the top number, so that's negative 45x squared. And the bottom number is 4x. So I'm looking for 2 numbers that multiply to negative 45. So I know I got to have a positive and a negative to multiply up to a negative. And that means when I'm adding them together, I'm actually finding the difference. So 2 numbers that have a difference of 4 that multiply to 45. Let's see, my options are 1 and 45. That doesn't work. 2 doesn't go into 45. 3 and 15. Nope, that's too far apart. 4 doesn't go in. 5 and 9. There it is. That's the one that I want. Which one should be positive, the 5 or the 9? 9, because I want to have a positive 4. So I want to do 9x minus 5x. And then you can put those in either spot up here. So I'm going to do 9x minus 5x. Okay, now I'm going to factor. The greatest common factor of 3x squared and 9x is 3x. So that goes there. If this is a 3x, that means this one has to be an x. So when I multiply them, I get 3x squared. 3x times 3 gives me 9x. X times negative 5 gives me negative 5x. And then double check. 3 times negative 5 is negative 15. So I know I factored it right. Okay, so the bad news is that's just getting me to the point where I can solve it. That's not the solving process yet. So now I have it in factored form. And it's equal to 0. So that means one of my 2 parentheses has to be 0. So that means x plus 3 could equal 0. Or 3x minus 5 could equal 0. If x plus 3 equals 0, I'm going to subtract 3 from both sides, and that gives me my first answer, which is x equals negative 3. 3x minus 5 equals 0. I start by adding 5 to both sides to get rid of that minus 5. That gives me 3x equals 5. Divide it by 3, and I get x equals 1 2/3. Or you could leave it as 5/3. I don't care. I really like improper fractions. I don't care if you put them into a mixed number, or if you give me a decimal, any of them are fine, but I like to just save myself a step and just leave it as 5/3. Why not, right? Okay, this one, x squared plus 6x equals 0. First of all, what form is it in? It's in standard form. Is it equal to 0?
Yes.
It is equal to 0. Okay, so that means I need to factor it. Now, it's missing a term. What term is it missing? It's missing the constant. When you're missing the constant, you can still do the area model and the diamond, or if you'd rather, you can take a look at these and say, what's my greatest common factor of these two terms? What would the greatest common factor of those two terms be? 1x. So the number, the greatest common factor of the numbers is 1, but one has an x squared and one has an x, so x is also part of the greatest common factor. So I can divide out an x, and if I divide an x out from x squared, I'm left with x. And if I divide an x out from 6x, I'm left with 6. And that gets me to my factored form. You'll still get the same thing if you do the area model and the diamond. You'll just have a whole row of zeros, and then it ends up just being x plus 0, or just x. Okay, now I gotta solve it. So now, these are the two things that are being multiplied. If it helps you visualize it by putting a parentheses around x to remind yourself, that's one of my factors, that's one of the things that's multiplying, go ahead and do that. Okay, so that means that x could equal 0. Oh, there's my answer. That was easy. Or x plus 6 could equal 0. And if x plus 6 equals 0, I have to subtract 6. And then my two answers will be x equals 0 and x equals -6. Almost all the time when you're solving quadratics, you'll get two answers. Not every time, but most of the time you'll have two answers. Any questions?